Hello! It's Valentine's Day. I would like to greet you all a happy Valentine. Once again, this is your math teacher, Joseph L. Saculias, LPT. So I'll be discussing about quadrilaterals, which will be our lesson for the first week of the third quarter. Okay, in our most essential learning competencies, the student should be able to determine the conditions that make a quadrilateral a parallelogram and illustrate the measure of sides and angles of polygons. Now, we'll be having a small game called Guess the Objects. So what you're gonna do is that you're going to guess what the picture is. Okay? So let's start. What is this object? Very good, it's chocolate box. Okay, let's go to the another picture. What is this? Very good, it's romantic table. Next picture. What is this? Splendid! It's golden earring. Next picture. What is this? Virtuoso! It's proposal ring box. Next picture. What is this? Excellent! It's greeting card. And the last picture? I'm so sorry, but the correct answer here is bitter melon or bitter gourd or balsam apple. So since it's Valentine's Day, magpapaka-bitter po tayong lahat. Wala po magwa-Valentine's Day dahil may klase. Just joking. Okay. So, we have to love everyone because it's the day of love. Okay, so love your neighbors, love your loved ones, love your friends, your enemies, and most especially God. Okay, don't forget that. Okay, let's go with our lesson proper. So our lesson for today is all about the properties of quadrilaterals, what quadrilaterals are, and what are quadrilaterals for. Okay. But what is a quadrilateral? Okay, so it is it is a closed two-dimensional shape which has four straight sides. The polygon has four vertices or corners. Okay, so let's digest this. Okay, so closed. So what do you mean by closed? It should be closed. Okay, the shape should be closed. In our illustration here at the right side, okay, so as we can see, the shape is closed. Okay, there is no open field there. And then two-dimensional shape. Is it two-dimensional? Yes, because it has length and the width. Okay, which has four straight sides. So in our illustration, these are all straight sides. So if you have noticed, a curved side, so automatically it is not a quadrilateral. Okay? The polygon has four vertices. When you say vertices, it is the plural of vertex. So what do you mean by vertex? It is the intersection of two rays. Okay? And then what something did we form if we connect two rays from the vertices? So there is an angle there. Okay, so when we have four vertices, automatically we'll be having four angles. Okay, so in our illustration here, for example, the green one, so we have four vertices here, 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 and here. Since there are two rays adjacent to each other, they formed angles. Okay? And that is all. And then they have 4 corners. Okay? So that is what quadrilateral means. Okay? So as you can see here in our illustration, all of the shapes has 4 straight sides. They are 2-dimensional. They are closed. They have 4 vertices and they have 4 corners. They are quadrilaterals. Okay. Now, we'll be tackling about the quadrilateral family, because we all know that a quadrilateral has different shapes and size and properties. Okay? As we can see here, there is different kinds of quadrilaterals. So let's identify each of them. Okay? So we have the most general, the quadrilateral. And then quadrilateral has 2 main subgroup. Okay? The first one is the trapezoid, and then the second one is the kite. Let's go to the trapezoid first. Trapezoid has 2 kinds. We have isosceles trapezoid and a parallelogram. Okay? So, parallelogram and isosceles trapezoid have one kind, which is rectangle. Okay? And then, in the parallelogram and kite, there is a rhombus, and rhombus and rectangle has a square. Okay? Let's identify them one by one. Now, let's identify what trapezoid is. Okay, so internationally we called it as trapezoid, but in the United States they call it trapezium. Okay, since we are using international language, we are using trapezoid, and this is what we used to. Okay, the trapezoid. Okay, and what is trapezoid? It is a quadrilateral, of course, with only one pair of parallel sides. So what do you mean by parallel sides? Two lines or 2 sides will never meet. Okay, in our example here, the pair of parallel sides here is the base at the top and then the base at the bottom. Okay, if we extend this length, they will never meet. Okay, they will never form a vertex or a corner because they will never meet. Okay, unlike here, the side here and the side here, when we extend that, they will meet and they will form a corner or a vertex. So therefore, it is not a parallel side. Okay, so in this side, they are parallel. Okay, once again, trapezoid, only one pair of parallel sides. That is the property of trapezoid. So what if you have 2 pair of parallel sides? Can we consider that as a trapezoid? Let's think. Yes, it is a trapezoid because we only have to satisfy one pair of parallel side. So if that quadrilateral has more than one pair of parallel side, that is also a trapezoid because there is a pair of parallel sides there. Okay? That is a trapezoid. Now, let's go to the second kind of quadrilateral, which is the kite. What is kite? It is a quadrilateral whose 4 sides can be grouped into 2 pairs of equal length sides that are adjacent to each other. So that is the only qualifications to identify that quadrilateral is a kite. Okay, when we have 2 pairs of adjacent. Okay, when you say adjacent, they are beside. They are beside to each other. In Tagalog, magkatabi. Okay, adjacent. So for example, here and here, they are adjacent because they are magkatabi. Okay, or they are beside to each other, and they are congruent. When you say congruent, equal. Okay, same length. and then the second pair is here. The second pair of adjacent side is here, and they are also congruent. In that case, it is a kite. Okay? Okay, so let's go to the first kind of trapezoid, which is the parallelogram. This is the most common kind of quadrilateral of all. Okay, parallelogram. It is a four-sided plane rectilinear figure with opposite sides parallel. So this is the only thing when we identify a shape parallelogram when it has two pairs of parallel sides. Okay, so here the first pair of opposite sides, they are parallel, and then the second pair of parallel side, it's also parallel. Okay, so therefore it is a parallelogram from the word parallelogram, so it must be parallel. Okay, the second kind of trapezoid is isosceles trapezoid. So the only qualification here is that, you know, one pair of opposite side must be parallel, and then the other sides must be congruent. So it should be in the same length. Okay, and that is isosceles trapezoid. Next one, we have the other kinds of parallelogram and isosceles trapezoid, which is rectangle. What is rectangle? It is a two-dimensional shape in geometry having four sides and four corners, of course, because this is a quadrilateral. Its two sides meet at right angles. Thus, a rectangle has four angles, each measuring 90 degrees. The opposite sides of a rectangle have the same lengths and are parallel. Okay, so this is also a kind of trapezoid because, you know, one pair of opposite sides are parallel, and then the other pairs are congruent. Okay, because according to the property of rectangle, opposite sides of a rectangle have the same lengths. So that means the opposite side, the two pairs of opposite sides are equal. So assuming that the other two pair of sides are congruent. Okay, so we have one pair of parallel sides and then one pair of congruent sides. I mean, one pair of opposite congruent sides. So therefore, it is a isosceles trapezoid. And then this is also a parallelogram because two pairs of opposite sides are parallel. And then the only difference between rectangle and the two is that rectangle has 90-degree angle because they meet, its two sides meet at right angles. Okay, so therefore all angles measures 90 degrees. Okay, we have the next kind of kite and a parallelogram, which is rhombus. Okay, so what is a rhombus? It is a parallelogram and a kite with opposite equal acute angles, opposite equal obtuse angles, and four equal sides. Okay, so why is it called a parallelogram? Because the pairs of opposite sides are parallel. And then why is it considered a kite? Because two pairs of adjacent sides are congruent, right? Because it is four equal sides. So assuming that this side is adjacent to this side and they are congruent, and then this side adjacent to this side, they are congruent. So therefore, it is also a kite. Okay, so the only difference between rhombus and a kite and a parallelogram is that rhombus has four equal sides. Okay, when a kite is if a kite has no four equal sides, therefore it is not a rhombus. Okay, if that kite has four equal sides, therefore it is a rhombus. Okay, yeah, that's it. And then rhombus are always parallelogram because the opposite sides of rhombus are parallel. Okay, but not all the time parallelogram is a rhombus, because there are some parallelogram like rectangle that has no four equal sides. We all know that rectangle is has two pairs of opposite sides, and they all of the sides are not congruent, right? Because only two pairs of opposite congruent sides, so it is not a rhombus. Okay, so once again, rhombus are always parallelogram, and parallelogram is not always rhombus. And then the most perfect quadrilateral of all time is a square. Okay, because a square has four equal sides and four equal angles. Okay, it is a rectangle because it satisfies the property of rectangle, such as two pairs of opposite sides, two pairs of opposite parallel sides, and then two pairs of opposite congruent sides. This is also a rhombus because it has four equal sides, and it is also a parallelogram because two pairs of opposite parallel sides. Okay, is it also a kite? Yes, because two pairs of adjacent angles are congruent. Okay, is it also an isosceles trapezoid? Yes, because one pair of parallel sides and then one pair of congruent sides. Okay, this is a trapezoid. Yes, because one of the pairs of opposite sides are parallel. Okay, so we can say that square can be a trapezoid or a kite or an isosceles trapezoid, parallelogram, rectangle, or rhombus. But rhombus are not always square, because there are times that rhombus doesn't have 90-degree angle. Then rectangle are not always square, because rectangles sometimes the length of the side is longer than the other side, like that. Okay, and then yeah, that's all. Okay, squares are always any kind of quadrilateral. Okay, so that is the quadrilateral family. But we have the freeloader here, but I do not say that this is a freeloader because it is kind of special thing in quadrilateral, and that is called irregular trapezoid or trapezium, but in the United States they called it as trapezoid. Yes, our term is different to United States, but we are using trapezium or irregular quadrilateral to make us lesser confusion. Okay, so what is a trapezium? It is an irregular quadrilateral with sides that are not all equal in length. Okay, so the only thing that matters here is that there are no equal in length. Okay, so the sides, not all the sides are not equal or congruent, and that's all. Can square be an irregular trapezium or trapezium? No, because square is a regular quadrilateral, so you cannot label square as an irregular quadrilateral. Okay, so since we are focusing on the parallelogram, let's talk more about parallelogram. So how can we identify a quadrilateral, a parallelogram? Okay, so the first property is that opposite sides are parallel. Okay, so the two pairs of opposite side should be parallel. Okay, in our example here, we use this symbol to identify that those sides are parallel, and then the second pair of opposite sides are also parallel, so therefore this is a parallelogram. Okay, the second property is opposite sides are congruent. Okay, we use these symbols to identify that those pair of sides are congruent. Okay, the first pair is congruent and the other pair is also congruent. So therefore, it is a parallelogram. Okay, and then the third property is that opposite angles are congruent. So surmising that this is the angle, and then the opposite angle of this angle is this, and they are congruent. They should be congruent to be parallelogram. And then the second pair of opposite angles should also be congruent. Okay, and then the fourth property is that consecutive angles are supplementary. What do you mean by supplementary? Supplementary is, is composed of two or more angles that have the sum of 180 degrees, just like that. Okay, so when you add two angles or three angles or whatsoever, and the sum should be 180 degrees. Okay, but here in our property, consecutive angles, so that should be two consecutive angles. Okay, and it is also called as adjacent because they are magkatabi or they are beside to each other. Okay, so the first example here, 110 degrees, and then the consecutive angle of this, it's either here or here. Okay, so 110 plus 70 should be 180. Is it 200? Is it 180? Yes. So therefore, it is supplementary, and they are parallelogram. And then the last property of parallelogram, diagonals bisect each other. So diagonal is the line from one angle to the opposite angle. Okay, so vertex or corner, from the corner to the opposite corner. Okay, and when you say bisect, two diagonals bisect each other because they cut themselves into two to each other. Okay, so this cut and this cut are congruent, and this cut and this cut are also congruent. Okay, and those are the properties of parallelogram. Now let's apply everything. Okay, let's have the first example. In quadrilateral PQRS, PQ is parallel. This symbol is parallel. Okay, PQ here is parallel to SR here, and PS, which is here, is parallel to QR. So is that a property of a parallelogram? Yes, but we need some more information. Okay, so PQ, the length of PQ is congruent to the length of SR, and then the length of PS is congruent to the length of QR. So can we conclude that this quadrilateral a parallelogram? Yes. Therefore, PQRS is a parallelogram. Another example. In quadrilateral LOVE, angle L is congruent to angle V. Why? Because according to our property, the opposite angles are congruent. Okay, since angle L and angle V are opposite angles, they should be congruent to call it a parallelogram. Okay, and then angle O is congruent to angle E. Same case to the first statement. So therefore, LOVE is a parallelogram. Illustrative example number 3. In quadrilateral HOME, the HT and then the MT, okay, once again, HT and then MT. So this applies to the fifth property of parallelogram. Okay, diagonals bisect each other. Okay, so it says that they are congruent, and then ET, which is here, is congruent to OT. Okay, so therefore HOME is a parallelogram. Illustrative example number 4. So the measurement of angle C added by the measurement of angle A is equal to 180 degrees. So they are consecutive angles, right? Because they're adjacent or magkatabi. So is it supplementary? Yes, because the sum of angle C and angle A are 180 degrees. And as you can see, all of the sum are 180 degrees. So can we conclude that this quadrilateral is a parallelogram? Yes. Therefore, CARE is a parallelogram. Illustrative example number 5. HEO here is congruent to POE. So we form triangle here. Okay, can we call that a parallelogram? Yes. Okay, because we have when we cut a parallelogram, we form two congruent triangles. Okay, two congruent triangles. So they have the same length of each leg and width or length or whatsoever, and they have the same measurement of angles. Okay, so since there are two congruent triangles, the measurement of angle P and the measurement of angle H are congruent. Okay, and as you can see, they are opposite to each other. Okay, and then HO, which is one of the sides of triangle, is equal to this side. Okay, and that is included to the property of parallelogram. So therefore, we can say that HOPE is a parallelogram. Okay, so identify the following. So quadrilateral JPST. So JPST. What kind of quadrilateral did we form? It's a parallelogram, of course. And then JT, this JT, and PS. So let's look at the symbol there, JT. So they have two line there, and then PS, two line there. So they have the same symbol, and what does that mean? They are congruent. Okay? Okay. A pair of congruents, a pair of opposite congruent side. Okay, angle J and angle P. Angle J and angle P. They are consecutive angles because they are magkatabi. And they are supplementary. Okay? And then angle T and angle P. Angle T, angle P, they are opposite. Okay? A pair of opposite angles. And then the last one, TP and JS. Okay? TP and JS. Okay, so we formed diagonals. Okay, so they are diagonals. Okay, so in letter B, complete the statement. Okay, so the length of JX is congruent to what? It should be XS. Okay, because according to the fifth property of our parallelogram, diagonals bisect each other. Okay, so therefore, JX is congruent to XS. Okay, next one. Angle J is congruent to what? Okay, should it be the consecutive angle or the opposite angle? The opposite angle. Okay, so therefore, angle J is equal to angle S. Blank is congruent to TS. So this is the TS. So what should be here? It's JP because according to the to the second property of parallelogram, two pairs of opposite sides are congruent. And then letter I, measurement of angle J plus the measurement of angle P is equal to, since they are supplementary, the sum should be 180 degrees. And then the letter J, TX is congruent to, according to the fifth property again, diagonals bisect each others. Therefore, TX is congruent to XP. Okay? And that is all. Be Valentine. Do you know what helps you make yourself beloved? Loving yourself. appreciating small things, and be open. And the most important thing, loving God. Okay, before we end this session, I will be reminding you about the expected outputs to be submitted on Friday and Saturday. Okay, the learning task, performance task, and reflective journal. This is the learning task, and this is the performance task, and this is the reflective journal. That is all. Thank you very much for listening.